So this is a continuation session of UML 2.5 modeling. So in our last session, we covered the basics of UML diagram and essentially the three types of UML diagram. So there are in all 9 kinds of UML diagrams. So rest 6 UML diagrams we are going to cover in today's session. So before beginning with today's session, let us have a quick revision on what we have covered in last class. So we have covered 3 kinds of diagram and the UML concepts, the object-oriented concepts in detail in our last session. So in our last session, we have covered something called as association, aggregation, and composition. So we'll have a quick revision around it. What is association, what is aggregation, and what is composition, because more or less in all of the UML diagrams, you would be finding these 3 things in whatever UML diagram you are doing in real practice. Now, you are going to tell me what is association. Anyone can start. What is your understanding around association?
Getting associated with a project.
Okay. What is aggregation?
Collecting information about the project, like how to go on with the project, what all we have to do for the project.
No, it's not about collecting information. In a project context, can you give me an example of aggregation? We have seen how we could model a system with the help of UML diagram. Can you give me a small example of how we can associate, aggregate in a project context, or how we can do a composition in a project context? Okay, so here are the typical examples. It's a very layman thing. For example, owner feeds pet, pet feeds please owners. So that's a direct association between owner and pet. There is nothing in between. Now, when we say composition or aggregation, the moment you hear the word composition or aggregation, they are more or less the same thing. So a tail is part of both dogs and cats. So tail is a composition for dog as well and for a cat as well. Now a cat is a kind of pet. There is something called as inheritance and generalization. So in our project context, for example, we say that a instructor would be having a student would be having multiple teachers or multiple instructors. So there's a direct association between a student and instructor. Similarly, this particular example indicates that every instructor has one or more students. So one dot dot star means more, and this is simply one. So one dot dot star over here, one dot dot star over here indicates multiplicity. So a student can be associated with multiple instructors. Multiple students can be associated with one single instructor as well. Similarly, multiple students can be associated with multiple instructors. For example, a single student can learn different topics from different instructors. Similarly, different student can learn a single topic from a instructor. So this way, in a regular system context, we can define the association either one to many to one, or many to many relationship. Now, this is an example of your association and one is an example of your aggregation. Sorry, one is an example of your aggregation and one is an example of your composition. Can anyone tell me which one is an example of aggregation and which one is an example of composition? Left one, is it composition or aggregation?
Composition.
Everyone has the same view. Left one is an example of composition. Left is an aggregation and right is an composition. So how do you differentiate between aggregation and composition? It's in front of you. Just closely observe. You would find the difference. Okay. Okay. In system designing, how do you differentiate between aggregation and composition? There is something called as notation used in this two diagrams. Can you identify the two kinds of notation in these two diagrams?
Maybe the arrows. Like one is
Yes.
dark.
The diamond symbol, which is filled, represents aggregation, and the diamond symbol, which is empty, represents your composition. Now, let me give you one more situation. Now, let me delete this person. What would happen?
And then they will not. So it's
Exactly.
dependent on the person.
Exactly. If I delete engine or this particular car, can engine and wheel standalone exist?
Yes.
Yes.
Absolutely. So that's the difference between aggregation and composition in a system designing context. So you need to ensure whatever component you are associating or aggregating or composing, you need to ensure that if I delete that particular thing, whether the other parts would be working in a working situation or not. In keeping that in mind, you have to define the association, aggregation, or composition relationship. Now, when we say generalization or something, what I would say, association, there is something called as generalization and specialization. Now, generalization is like we have a typical bank account. Now, in that particular bank account, we may have savings account, we may have credit card account, we may have loan account. So, from bottom to top, it is called as generalization, and from top to bottom, it is called as specialization. The diagram would be same, but if we consider a bottom-up approach, the diagram would be read as generalization, and if we consider top to bottom approach, the diagram would be considered as specialization. So specialization is the reverse process of generalization, means creating new subclass from an existing class. For example, we had a existing class as bank account. It has typical set of variables, it has a typical set of methods, it has typical set of attributes. Including those attributes, we created different subclasses out of it, like savings account, credit card account, and all XYZ details. Now, can anyone tell me what would be the common element? Can anyone tell me what would be a single, name me a single attribute which would be common across bank account, savings account, and credit card account? Any single attribute. It's very simple.
Account number.
Yes. No, account number won't be. Account number would be unique for every thing.
Name of account holder.
Yes. The name of account holder. That would be common. Bank account holder's name would be same in the savings account, in the credit card account. Then the address may be same, may not be same in some cases. So it depends actually. But name is the unique thing. The birth date that is mentioned in your bank account details, that would again be same. Then your gender would be same. Then the transaction pattern like credit debit pattern, that would also be unique in some of the cases over here, because whatever savings account you are having, If you are using the same savings account to make a credit card payment, so there would be a debit in your savings account and then there would be a credit in your credit card account. That is, you have paid the bill. So, can anyone tell me what would be that element which would help us inherit savings account and credit card account from a particular bank account? What is the typical attribute that would relate these three? Now let's say I have a bank account. With that particular bank account, I have a savings account associated to it and a credit card account associated to it and a loan account associated to it. There is a common element that would connect these three accounts. Can anyone identify me? What is that common element? It is unique in nature, to give you a hint.
Member PIN number?
I would say customer ID in that case.
Okay.
So customer ID would be unique. Okay. So same customer ID would be used for your savings account, for your credit card account, and for your loan account. For XYZ, any number of relationship you derive out of this bank account, the customer ID would be same. So in database context, that customer ID is called as primary key. And whoever is using those IDs in that respective structure, like savings account, credit card account, or loan account, they are treated as foreign key. So primary key would be your customer ID, which would reside in your bank account, and whoever is referring that primary key would be treated as foreign key. We will see those concepts when I cover your database modeling concepts in a later session in detail. Okay, so in today's session, we are going to start with our first diagram, that is your sequence diagram. Now, this diagram is essentially used to document a system's requirement and from a system designing context. And the reason for sequence diagram is to show the interaction logic between the objects in the system in a time order that in which the interaction takes place. So we have certain elements that we need to take into consideration when we are working in a sequence diagram. So classes and objects would always be part of your interaction diagram as they are dynamic in nature. So whatever interaction would happen, that would happen in your sequence diagram itself. So whenever we are initiating an interaction between different objects, there would be classes and objects concept that would come into the picture, deriving out of your object oriented modeling concept, which we covered in our last session. Now, a sequence diagram is your interaction diagram that details how operations are carried out, what messages are sent, and when, and they are organized according to a particular time. For example, you are processing a transaction, so a message is sent in a timely manner. So whenever you are processing a transaction, let's say you have made a payment via credit card or your ATM card, and you are opting for your one-time password authentication. So whenever you are receiving that one-time password, that is valid for next 10 minutes or 15 minutes. After that, the message expires. So why it expires? Because there is a time associated to that particular sequence of event. So whenever the OTP event is generated in a particular system and the outcome which we get a unique one-time password, that has a validity because sequence diagram are mostly time-driven diagram. So if you don't put that particular password or one-time the authentication in that stipulated amount of time, 10 minutes or 15 minutes, the workflow won't move further and it would ending over there. So they list objects in horizontally and time vertically, and the models these messages over time. So whenever we are creating a sequence diagram, we essentially denotes the objects in an horizontal manner and the time in a vertical manner. So that is the process that we need to follow when we are creating a particular sequence diagram. So these are the typical elements in a sequence diagram. As we have seen in most of the UML cases, the actors are represented in this human skeleton form. Then we have an object. Objects are represented in this particular rectangle form, and we have to write the name of the object, for example, student. Then there are units, which could be a component or which could be a subsystem. They are denoted in this square fashion, square box. Then there are separators. It represents an interface or boundary between the subsystem or component. So whenever we are working in a particular software designing uh, uh, environment, we would be having multiple different systems to interact with. So this particular separator or this particular line would indicate that it is interacting with a different part of a particular system. For example, in an online shopping portal, we have our own web interface. Then that web interface would be interacting with the server. Then the server would be interacting with any payment gateway interface if they would be having. So all of these three elements, the web UI wherein we are placing the order, the server of the e-commerce website, that system, and the payment gateway system, they all would be separated by this line, that is separator. Then we have group. So it relates the header elements into the subsystem or component. So if we would like to model 2 or 3 subsystem into a particular group, or for that matter a particular object or unit into a particular group, then we have that flexibility of doing so in a sequence diagram. Then we have messages which are passing in between the system. So they are represented with this arrow symbol. Then we have something called as synchronous message and asynchronous message. Can anyone tell me what's the difference between synchronous message and asynchronous message? Mhm. And what about asynchronous? Okay, so let me give you an example. You tell me whether it's an synchronous messaging example or asynchronous messaging example. Okay, so there is a product that you are trying to purchase in an online system, and you generate a request to purchase that particular product. Okay, now before purchasing that particular product, you have seen that the product was available at that point of time. The product was available. That's why you hit on that buy now button. Now when you go to a checkout screen, you see the product is out of stock. So can you tell me what kind of messaging mechanism it has triggered, synchronous or asynchronous?
Asynchronous.
It's synchronous. Why is it synchronous? See, whenever you have visited the online shopping portal, you have verified the products, and you click on buy now button. Now after buy now button, when you click, it actually internally sends a synchronous message to the inventory module and checks whether the particular product is available for purchase or not. Okay, so it triggered it. At that point of time, the product was available in the inventory. But when you went to the checkout page, again it sent a synchronous message to the inventory system. But at that point of time, the product was not available in the inventory. Hence, you got the messages the inventory is out of stock. So, what happened over here is there is a consistent communication between the systems, the inventory system and the online web interface system. So the message passing mechanism or the messages sending and receiving are instant in nature. They do not have to wait for a period of time. So when it comes to synchronous message, the wait time is almost negligible. But when it comes to asynchronous message, it's not guaranteed that you would receive a response immediately. So there is a time associated to it. To give you a very simple example, when you are calling someone and he received that particular phone call. So Is it an example of synchronous message or asynchronous message? You are calling someone, he received the phone. Yes, absolutely.
Synchronous.
You are sending an email to someone. Is it a synchronous message or asynchronous message?
Asynchronous.
Absolutely. So it is not guaranteed that he would reply in that particular amount of time. So synchronous messages are two-way message passing mechanism, whereas asynchronous is a one-way message passing mechanism. In other words, you could give an example of your phone call or your email message. Now, the next part that is there in sequence diagram is creating a message. So whenever your system is generating a message on a particular event, like on a click of buy now button or on a click of checkout button, so that is the point when your messages are created. So you need to identify which is the event that would trigger the message, irrespective of whether it's a synchronous message or it's an asynchronous message. And you have to also identify when it would destroy the particular message. Now, once you have checked out that particular item, and let's assume a case that the item was available for purchase. Now, there is a need that we need to destroy that particular message because our purpose is solved. The item was available and we did the checkout and we made the necessary payment. Now, can anyone tell me why there is a need of destroying a message? Why can't I keep the message like that? Why would even I care? Why there is a need of destroying that particular message?
Maybe security belief.
That is one reason.
Uh, Database storage space.
Okay. Any other thought? Okay. So what happens essentially in sequence diagram, whenever you are initiating a particular message passing mechanism, there's a lifeline associated to it, or there is a temporary life created. So every system would be having a workflow. So I'm referring that workflow as a life. So every person would be having their own set of life cycle in that particular sequence diagram. So you are going for a shopping, let's say Kshitij is going for a shopping. He has initiated his own set of life cycle through messages and objects. He has created his object and his object is interacting with the system with the help of message. At the same time, Shivani has initiated a particular purchase in that particular system. She has created her object and that object is interacting with the system with the help of the necessary message passing mechanism. Now, after I have purchased, if I don't destroy this message, what would happen? The system has an what I would say has an ability that they could reactivate that message, and that in turn would affect the other parallel message passing infrastructure that is happening within the system. So in order to avoid those unnecessary call between each other's messages or each other object's messages, we are supposed to destroy messages or define a time wherein the message should be destroyed. And the other reason, like someone rightly said, that it would increase the memory capacity or the memory usage. For that reason also, we need to ensure that the whatever messages are created after they have gone through a particular set of life cycle, particular set of processes, they are appropriately deleted. Now action is something wherein an event would trigger, like buy now, purchase, and XYZ. Page break is something in an event of an error, what should happen. So we represent it through a page break. Now block, loop, or conditional. If there are any loop that you would like to traverse through in a particular system, that is depicted with the help of this particular item. So in software industry, we have different kinds of loop, like if loop, for each loop, if then else, if then loop. So those kind of loops can be depicted with the help of this block. Then we have return message. Whatever message we have sent, we would be getting something in response to denote that we have return message. Then if we would like to add some additional information, we can do it with the help of free node and flow node. So flow node is something that would be added whenever you are depicting a flow, like returning or sending a message. If you would like to add something over here, you would using flow node. And free node is like if you would like to add some additional information around the units, around the objects, you could use free node. And then there are diagram link, which are defined by these elements. Now let's see what are how do we map these elements in a particular sequence diagram. Now here we have some objects, like we have a patron, his name is Fred. We have a waiter, his name is Bob. We have a cook, his name is Hank. And we have a cashier, her name is Reem. Now, the patron is coming to that particular restaurant. This is a use case of a restaurant. Now, the patron is coming to that particular restaurant. He orders a particular food. And how he is ordering that particular food? He is requesting that particular food to waiter. Now, in order to prepare that food, what the waiter would do, he would go to the cook, that is Hank. Now, after Hank has prepared the food, he would give it to the waiter. And after that, the waiter would serve the food to the patron, that is Fred. Now, at the same time, while Hank is preparing the food, if the restaurant culture is like they have to serve free wine, then waiter can do so. He could serve free wine. For that, an approval is not needed from the cook. That is something the restaurant's policy, to serve free wine. So he is doing that. Now, here, whenever these particular things are completed, after that, once the patron, that is Fred, is happy with all this process. He has ordered the food, he got his free wine, he got his free food. Now what is the next step? Next step is to make the payment. In order to do the payment, he would directly go to the cashier, that is Reem, and that is when this thing stops. Now if he doesn't make a payment, then you have to initiate the alternative methods. What could happen in this particular scenario if he doesn't make a payment? So that's the reason why there is a cross, and here is where this particular event ends. So for Fred, the event starts with ordering a food and ends with making a payment. For Remy, the cashier, the event starts and ends with receiving the payment for whatever food he has ordered. For Bob, the event starts with accepting order from the patron, that is Fred, and serving food to the patron, that is Fred. So his event starts from ordering food and ends with completing food. Now for cook, his event starts from accepting the order, preparing and delivering that particular order to waiter, that is Bob. So his event ends starting at the preparation of food and ending after preparation of food. So this is a general example of a sequence diagram. So here we have represented the objects. Here we have represented the sequence, like from sequence 1 is 1, 2, 3. Then sequence 2 is this. Then sequence 3 is this line. And sequence 4 is this line. So we typically have 4 sequences over here. So in between these things, there is certain time associated to it. So if you want, you could define the time in and around it. Like ordering a food would take 2 minutes, placing that order would take 3 minutes, 2 to 3 minutes. Here preparation time, it would take 15 minutes. If you would want to depict that, that also you could do with the help of sequence timeline. Now let's see example wherein a student registers for a class through a web interface. Now both the course and full course open scenarios are shown over here. So let's say I am an object. So these are the sequence that are happening. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 17 sequences are there. And we have created the starting point, the student who would be initiating that particular sequence. Then we have the web browser, the computer website wherein he would be searching for that particular class and registering it. And then we have a grouping of web server wherein there would be a web server, there would be a registration page, there would be a student, there would be a course in that particular web server itself, and eventually we would be having a database backed by this web server. Now here what essentially is happening, the student is browsing to the automated registration system homepage. Now this particular system is automated, there is no such manual intervention. So the first sequence of event, what is happening, the student comes, he browses to the home page. That's a very obvious thing. Whenever you would like to register for a class, you visit that particular institute's website and you start browsing the home page. After that, whenever you are browsing through that particular home page, there is an internet connection consistently available to you. So with the help of your internet connection, you are making a request to the home page, which goes to the web server. Okay. After processing that request, the web server sends the response to the UI browser, wherein the local system, wherein the particular student is browsing this particular website's homepage. So whenever you are logging into a particular homepage, there is a request and response happening between your client and the server. Client is your laptop or desktop. Server is the actual location wherein the application is hosted. This website's application is hosted. So you are requesting the particular homepage, so server responded. Now what happens in the fourth event, the student clicks on the registration link in the home page and select registration page. So whenever, when the server returned him the home page, he saw a registration page in that particular home page. So what he does next in the fifth sequence, he requests registration to the web server with the help of internet, which is consistently available to us. Now, when this particular request is received by the web server, so the web server checks whether the student is logged in or not. If the user is not logged in, then he has to perform the login procedure. So he has to do a registration. If he is a logged in user, then he has to log in. A new page is prepared and it is sent to this particular student, which is saved in that particular web server. So what essentially happening over here is, the moment this particular student is requesting for a registration, the web server create an object of that particular student. So he as in the web server essentially creates an object of that particular student with the help of a student ID, which is unique in nature. So every time multiple students would come to this particular registration, multiple objects would be created. Now this object creation can be sequential, can be parallel, depending on what location we are accessing this particular web page through their UI browser with the help of internet. Now a student object is created. After that, the get registration method is called and it is sent to the database. So database stores a copy of that student object and it returns the information that comes to the student object, and the student object renders that particular page, which is of late returned to the UI screen, to the UI browser, as your registration is completed. So whatever sequence of event that is happening between these lines, the web server and the course, this is taken care of by your programmers. So whenever you are writing these methods like new in the bracket page, so this is a new page creation method. Prepare is initiating this particular page method. Then initialize, you are initializing a copy of the registration page. So you need to consult the developer because this method name would exactly resemble the method name which are present in the code. So before writing these method names and these sequence, you have to consult a particular developer that I am writing this method name, am I going right on that part or not? That is the reason why these are more developer friendly UML, the sequence diagram. Here you would see the methods or the parameters which are more developer friendly rather than business language. So towards the end, we receive the response that the particular request for registration has been successfully completed. Now, if in case error happens, if the slots are full for that particular request, then you could depict over here that the slots are full. At this point of time, you cannot register further.
Hello?
Yeah.
So for creating this sequence diagram, we needs to be in touch with the developer, right?
Yes, absolutely. Because these methods, if you see the prepare, the initialize, you won't be able to define these methods. These are something your solution architect or the technical architect or the developer team would be able to tell you. And those methods are something that you need to describe in sequence diagram. So this is one more example of your sequence diagram. We have a web user interface and we have a hotel chain, and under that hotel chain we have a particular hotel. So hotel chain is like the hierarchy of hotel. For example, we have a hotel chain like Radisson Blu. So Radisson Blu would be having multiple hotels in different locations. So a user is coming to a web browser, he is making a reservation or he is requesting a reservation. Now it goes directly to the hotel chain website, and from the hotel chain website it is routed to the appropriate hotel wherein the rooms are available depending on the criteria which he has specified, whether he needs room for 1 day, 2 day, 3 day or 4 day. And similarly, if the registration is successful, he would get a confirmation. Yeah. Okay. So dotted line depicts, yeah, please go on with your question. Okay. So let me go back to our elements. So here, essentially, when I spoke about this thing, for each element. So not for each element exactly. Okay. So there is something called a separator. So solid line are essentially your separators. So wherever you see solid line, they are all your separators. And dotted line is something that are in between systems. For example, you have created a group of web servers. So essentially, your UI browser would be interacting with the web server first. Now, web server in turn would be interacting with multiple different components within that particular system. So all of these components, and if it is time driven, it would be having dotted sequence. And if it is not time driven, it would be having this particular solid sequence. So in this case, it is essentially dotted sequence. It's because there are multiple arrows over here, you would be finding it as a solid line, but it is not solid line. It is a dotted line because it is having a time sequence associated to it, for which the sequence diagram ideology sits behind. And these dotted line, the 1, 2, 3, 4, the numbering sequence which you see, that is something that denotes the sequence. So 1, what is the sequence of messages? 2, what is the sequence of messages? Else, the solid diagram are nothing but your separators. Okay. So in what cases we would be using sequence diagram? When the components are being developed in parallel by different teams. So essentially you have to collaborate with your software development team. And you have to support robust interface covering multiple scenarios. Like we have different interface over here, like UI browser, web browser, registration page, then the student object, course object, database interface. So since there are multiple interface over here, we were using sequence diagram. So main thing that you need to take into consideration while developing a sequence diagram, first is the number of interface, and second the timing between these messages. And it also helps us in elaborating our use cases. So we have seen the very first thing in UML, the use cases, they were more functional in nature. Now how do we elaborate it further with the help of sequence diagram or any XYZ diagram in a UML context? Okay, so collaboration diagram is something that we would use in combination with the sequence diagram. When we are creating sequence diagram, we would be creating collaboration diagram. Now, collaboration diagram are essentially used by designer to define and clarify the roles of the object that perform a particular flow or events of a use case. So we have different objects with us, like we have a web interface object, then we have a web server, we have a database object. Within those web server database objects, database server, what are the different objects, what role they would be playing, that is something that we would clarify with the help of collaboration diagram. Now this is again a type of interaction diagram. Now your sequence diagram and collaboration diagram are part of your interaction diagram itself. So it collaborates the static and dynamic relationships, and it focuses on object roles rather than timing. In sequence, we put special emphasis on timing, but in collaboration diagram, we put specific emphasis on the object roles, what they would be doing. So if you see this particular object, the web user interface, again we would take an example of that hotel chain. So in the first thing, it is doing a reservation. So hotel chains objects intention is to accept the reservation and do the necessary reservation with the available hotels which are there under their particular hotel chain. So 1.1 focuses on making an reservation, that is hotel chain. Now 1.1.1 is again focused on making reservation by accepting the reservation from the main hotel chain. Now this hotel would be responsible for checking if the rooms are available or not. That is 1.1.1.2. That is the next sequence. Here we are not putting emphasis on timing, rather than we are putting emphasis on what these individual objects would do. After that, it would check the reservation. If it is available, it would give a confirmation. That would happen in 1.1.1.2.1. In 1.1.2, we would check whether the hotel rooms are available. In 1.1.2.1, we would check whether after we have checked the reservation is available, we would send out a confirmation. So this way, we would focus on the objects which are created. So these particular things are nothing but your objects that are created for that particular sequence diagram. Now if it would have been a sequence diagram, it would have been something like this, wherein we would have considered the timing part associated with it. But since it's a collaboration diagram, we would only focus on the object part. Now this is another example wherein we compare the sequence diagram versus collaboration diagram. So this is a reservation of a copy of book in a library system. So there is a library member, then there is an UI, the library homepage, wherein he would be logging in and doing all these actions. Then there are member, then there are book, then there are copy. So these dotted line would denote the timing part, after what interval the next communication would happen. So you see this particular arrow in the right and this particular arrowhead in the left, and in between the gap, this is essentially the timing part which the sequence diagram would take care of. When it comes to collaboration diagram, it would look something like that. We would see it in a while. First, we would see the sequence part. So in sequence part, the member wants to reserve a copy. He accesses the details via the UI. After that, he validates the membership, whether he is a valid member or not. How the membership is validated? By the library database, which has all the list of the members who are available in that particular library. Once that is validated, it would check whether the title he wants to reserve, whether it is available or not. So it would check through the available titles in the database of the library system. After that, if it is available, the UI would make a request for reserving that book, and at the same time the UI would also change the status to R as a reservation. After that, it would set the alert on what date this book is due for, after 15 days or 7 days. Only after all these things are performed, and status would be sent to the member that your book is available, the book is reserved, the status of the title is changed to reserved, and your due date is of 15 days, and the member would be able to see that particular thing in the screen. After that, if there are any due that are there in that particular book after, let's say, 7 days or 15 days, it would send overdue notice to the member, or would display that particular overdue notice in that particular UI. So you could see at a point of time 1, 2, 3, 4, 5. 5 events are triggering in the UI at the same time. So these are called as parallel triggering of the events. So whenever he is accessing the details, 5 events are what I would say triggered parallelly. So there is no limit on how many events you are executing parallelly in a particular sequence diagram. So you could execute as many number of events parallelly at the same time. So that is what this particular diagram depicts, the sequence diagram. Now when we compare this sequence diagram with a collaboration diagram, we have these things. We have a member, we have a UI, then we have a copy, we have a book, and the actual member. So this is the member database, this is the library UI, this is the book database, and this is the necessary reservation information which is stored across the membership, like how many number of books he has ordered so far, how many books are in due status, how many books are returned, or how many books he has reserved. Those information would store in this. So here the member comes in, he reserves, he puts a request for reserving a copy. At the same time, these 3 events are triggered in parallel. That is, to the member database, it checks the availability, it validates the membership details, it checks the privileges of member, whether he is authorized to issue the book or not. After that, he uh, what he sends that parallel request to the book library. He checks whether this particular book are available. If it is available, he marks it as reserved. And at the same time, he creates a copy wherein it's check the status, change status, and set alert of his first due copy. Now, when member logs into this particular UI of that library system, he won't be able to see these things and this thing. He would only be able to see this thing, copy. So member privileges is only to verify these details like statuses, changing statuses, and alert of his due date. Rest, these 2 things are something the UI is taking care of. So in actual practice, if you see these 2 are something behind the UI, the member database and the book database, and the copy is something, the status that is available on the page to the member, which he could see. So again, there are 3 things or 3 events that has executed in parallel. 1, 2, 3, 4, 5, 6, 7 sub events that have executed in parallel. So here we have focused more on the objects rather than the sequencing, the time part. So that is the difference between sequence diagram and collaboration diagram. Any questions so far? in sequence diagram and collaboration diagram. Okay, so next type of diagram is your state chart diagram. Now, it is used to model the dynamic nature of the system. That is, it defines the different states of an object during its lifetime. To give you an example, when you are placing an order on a particular web application, you, if you are habitual about tracking the statuses of your order. So first status is order placed, then order packed, order shipped, then order ready for delivery, order out for delivery, and finally the order is delivered. So the product is same, but the states are changing. States are changing as in until and unless you get the physical copy of that particular product, the order status keeps on changing. So that is something you could highlight or elaborate with the help of your state chart diagram. You have to define the different states of the same object. To give you a very simple example, the traffic signal. So it has different states like red, then yellow, then green. Green means you could go, red means you have to stop, then yellow means that okay, there is very less time, you have to start preparing either to stop or either to go. So the object is same, but its states are changing, its states are transition. That is something you have to elaborate with the help of your state chart diagram. So it shows the possible states of the object and the transitions that cause a change in system. For example, logging in can be factored into 4 non-overlapping states, like getting social security number, getting PIN, validating, and rejecting. So essentially, your logging object is having these 4 states. Your getting your social security number, getting the PIN, then validating and rejecting. The object is same, but the states are changed. This is an example of your online banking system wherein logging is consist of entering a valid social security number and personal ID. So if you are entering, you want to enter to that banking application with the help of your SSN number or your personal ID. So once you click on login button, these are the 4 states that are changed behind the scene. If it is validated, then you are allowed to see your account's dashboard. If it is rejected, then you are restricted from accessing your banking account details. Now, they are in the form of rounded rectangle. Transition are depicted with the help of arrows, and the event or condition that trigger transition are written besides the arrows. And this is how it looks like. Now, these are essentially your states. These are essentially your transition. And whatever events are happening, that you could write beside the arrow. So this is again a traditional phone state chart diagram wherein the phone state is idle. So remember your traditional landline phones wherein you receive a receiver. When you receive that particular receiver, you get a dialer tone. After that, your dialer tone keeps on playing. After 15 seconds, it gets timed out. That is where it gets ended over there. After that, let's say a case wherein you start dialing a particular number. You receive a dialing tone over there. After that, if it's an invalid number, the event or the transition stops over there. If it is a valid number, it keeps you connecting. Now in connection also there are 2 things. Line may be busy or it would get connected. If it is busy, you would get a busy tone. If it get connected, it would start ringing on the other person's phone number or the landline number to whom you are calling. If he starts talking, if it gets connected, he or she, that person starts talking to you. After that, the caller answers your phone call and it gets hanged up. And in any case, if there is a disconnection happening, then again the entire process gets hanged up or disconnected, and again your receiver is in idle mode. So essentially, the receiver has transitioned into these states, and between certain amount of time, these things were happening. This is an example of traditional dial tone that are embedded in a particular landline phone. So this way you could create your system's state chart as well, depending on the need. Now, the order placement example I gave you, that is something you could model with the help of your system context when it comes to state chart. If you consider an insurance domain project, so a policy has different states. If you consider a billing part, so billing would trigger different states for a policy. For example, lapse of a particular policy. If you don't make a payment in a specific due date, then the policy would lapse. After that, if you make a policy payment, then the policy is revoked or reinforced. So those are the states that are associated with a typical policy. So the transaction or the transition that are happening to a typical insurance policy can be modeled with the help of your state chart diagram. Next, we have activity diagram. So activity diagram is an essentially flowchart diagram. Now, both activity and state chart diagram are related in certain way. For example, state chart diagram focuses attention on object going under a process who is transitioning the state, which we already saw in our state chart diagram. Whereas the activity diagram focuses on the flow of activity involved in a single process. So whatever flow is happening between those activity is something that is denoted with the help of your activity diagram. So these are the elements within an activity diagram. This black dot is your initial activity. This rectangle, ellipse, rectangle kind of thing is your activity description. Decision is something, if you have a decision to make, you would denote with the help of this diamond symbol with 2 arrows. And once your activity is ended, you would be having this rounded circle with a dot in it to show the end of that particular activity. If there are some input signal, you would be having this particular shape, and if there are output signal, you would be having this particular shape. And if there are some concurrent activity happening, let's say one particular event triggered multiple activity, then you could depict it in this particular way. So one activity, there are multiple sub activity, concurrent activity happening. After all of them are executed individually, the final activity would again process after that. For example, listening to a lecturer and looking at the blackboard is a parallel activity. This is represented by listening and reading activity. So the final activity would be the end of the activity diagram over here after all the activities are done in a particular system. So this is an activity diagram of an ATM machine. So we have a customer over here, we have an ATM machine, and we have a bank server. So when the activity starts, that's the dark dot over here or dark circle. After that, we have to start with the activity name that customer inserts the card in the ATM. After that, he enters the PIN. After he has entered the PIN, the activity would be triggered in the banking server to authorize it. Now, in the authorization, there are two things that would happen. There would be a case wherein the customer has entered a valid PIN, or there would be a case wherein customer has entered an invalid PIN. So let's consider it's a valid PIN. So banking server gave a confirmation that a customer entered the valid PIN. Then the ATM would ask the customer to enter the amount. After he has entered the amount, the banking server would check the account balance, whether the balance is sufficient or not. So there could be two cases. The balance would be sufficient or the balance would be insufficient. So if the balance is sufficient, it would go and notify the ATM machine to dispatch the cash. And after that, the customer could take the particular amount from that particular bank account. Now let's assume a case, the PIN entered is invalid. If there is an invalid pin entered, it would directly go to this decision and it would eject the card and customer would take out a card. Now let's consider a case wherein the account is insufficient. The account balance is insufficient. In that case, it would go to this particular ATM machine. It would show the customer balance that your balance is this much. You entered the balance which is more than your maintained balance in the account. In that case also, it would eject the card. After the card is ejected, the customer would take back his card and the process would end over there, which is depicted by a circle with a dot inside it. So this way, not only you have to make the decision, but you have to also identify where is the right decision you have to make, so that you could combine the input of multiple activities and the output of multiple activities. For example, here enter amount has triggered a decision, and the what I would say, the pin entering is also triggered a particular decision. Both the thing has triggered two different decisions over here. Now how do we simulate both the decision and combine and map it to the ejection of the card? That is something that we need to take care of when we are dealing activity diagram. Okay, any questions, anyone so far? Sequence, collaboration, state chart, activity. Looks simple, but when you start modeling it, you would have some challenges initially. Okay, so the next set of diagram is your implementation diagram. Now implementation diagram is divided into two sets of diagram. One is your deployment diagram and one is your component diagram. So let's first understand what is the deployment diagram. So it shows the dependency among the software components. For example, the source code component, the binary code, the executable components. So wherever you are having a package or a component, that particular thing would be mapped with the help of your deployment diagram. So deployment diagram is essentially for mapping of the individual independent components within the system. So package diagram can also be considered as a part of deployment diagram, which we saw in our last session. Now this is a typical example of a library system. Now these are the component, the library server, the library client 1, library client 2. Now what is client 1 and client 2? So let's say Kshitij is accessing the library server in one particular system. He is treated as client 1. Let's say Shivani is accessing the library system from her laptop. She is client 2. Let's say I am accessing the same library server from a different laptop. Then I would be client 3. So there would be client 1, 2, 3, 4, n. So these particular components would be mapped in this particular manner in a particular deployment diagram context. So you would be having your library management system. You would be having different client members. And then there would be a particular librarian who would be taking care of all the accountability. So he can be associated with a different client as well, because librarian may not be using the physical library server. He would also be using it in his laptop or desktop or at the reception of the library. So again, it's a computer system. So that's the reason why it is named as client 1, client 2, client 3, client n. Now coming to the component diagram, so these are the certain components which you need to take care of when you are doing a component diagram. Then you would be having your class in this fashion, your interface in this fashion, and object is your square. Now can anyone tell me why there are 3 sections in class and 2 in interface and only 1 in object? Okay, in class diagram, what would go in the first part? And the second part and the third part? We have already seen it and covered multiple times.
The name of the class?
Correct. After that, the attributes of the class.
Yes.
After that, the method of the class. So that's why there are 3 lines. For interface, it would be the name of the interface and the attribute of the interface. For object, only name of the object. That's why these 3 different rectangles to denote them. After that, we would be having realization and association, as we have already seen what are these things. And when we consider the same example that we considered in the case of deployment diagram, we tend to map it in this way. The librarian system, the client librarian, and the client members. So there will be X, Y, n number of members for that particular library system. So that's all for today's session. Any questions? Now coming to the hands-on part, I have this set of diagrams already documented with me. I have a sequence diagram with me, collaboration diagram with me, state chart diagram with me, activity, deployment, and component diagram with me. Now I'm going to show you how to create these diagrams using Visio. Now Visio is another tool which you could use for modeling your requirements in terms of unified modeling language. So this particular tool would be available to you by your organization, depending on which organization you work. If not available, we have other options like Glyphy or Lucid Chart or Argo UML. There are many options which are available which you could use to create these diagrams. Now Visio is a paid tool that is available from Microsoft, which is extensively used in organization for creating your UML diagrams. So if you would like to go for open source tool, then Argo UML is a good option. Otherwise, you could use your Lucid chart as well. Now, in order to create a sequence diagram, we would first need to do necessary setup. So let me start with the setup part. So what you need to do is you have to click on more shapes, go to software and databases, and go to software. Here you would find all set of diagrams or the notation stencils that are available for your usage. For example, right now we are creating a sequence diagram, so you would be using sequence. So here we have the necessary sets of diagram which are part of your UML sequence diagram, which you could use for creation of these diagrams. If we see our example over here, we have these 4 object lifeline. So what we are going to do first is we are going to drag 4 object lifelines into this canvas, drawing canvas. So let me first arrange them. So here I have dragged them and now I have successfully arranged them. So ensure you have enough space in between so that you could show clear interaction between these diagrams. So you have to increase the length of the lifeline for each of these objects that you have dragged. So I want this much length to be there. So rather I would align with the graph over here, how it goes with the graph line. I don't want anything in between these lines, so I would drag it over there. Now we have certain design consideration. I want the object color to be green, so I would click on it. If I want the object color to be orange, I would do it so here I would like to make my object color as blue. So I have created objects. Now I'm gonna name this object. So what I would do, I would click on it, go to home and click on this. So let me name it as Fred I would bold it. Now who is Fred? Fred is a patron. So colon, I would write it as patron. Capital P-A-T-R-O-N. Patron. Okay. I would again go back to my pointing tool. So whenever you would like to name it, click on it and click on in this text button over here. So what is the next object? Bob the waiter. So I would write it as Bob colon W-E-I-T-E-R, waiter. I double click on it and I would make it as bold. So the next object is Hank the cook. So I would go for Hank colon cook. After that, what is my last object? My last object is Rini the cashier. I would write it as Rini, R-E-N, Rini. She is the cashier. So it's not R-E-E, it's R-E-N-W. Now I am done with this thing. I would go to my pointer tool back. If I want to make it, okay, sorry. I would again have to click on this text and make it as bold. Same thing over here. I would again double click on it, bold. After that, I would again go back to my pointer tool. Now what I am going to add is the activation line. So for activation line, I don't want this big activation. So I would drag it. Okay. After that, in the similar line, I would do another activation. After that, I want two more activations over here, two more activities to denote. So I would drag it, two more activation lines over here. After that, I need a third activation line somewhere over here. Now, see the spaces in between these. Okay, you have to ensure they are well placed in terms of showing the activation. Okay, so I have placed it over here. You could see one arrow would come from there and the other arrow would go from there. Now we would first highlight the order food. So for that, I would create a message line from here till here, and here I would like to add text. So what I would write as in the text, order food, and if I want to make it bold, I can do so. After that, I would return back to the pointer tool. So order food is done. After that, that order would be received by waiter and it would go to the cook. So again, I would create a message from waiter to cook. Okay, let me increase the size of it so that you could see it clearly. After that, I would take this this thing and align it properly, and I would write it as sorry, I would delete it because the shape somehow didn't go well. Here I would write it as order food, and I would select it and make it as bold. After that, I want the next set of sequence. So next set of sequences, serve wine. So in order to do that, I would be creating a message. Sorry, I have to first switch to the pointer tool. So I will create a message from here that's the return message. In that context, I would write it as serve wine. So here I would draw that particular text. I would write it as serve wine. Meantime, his order is getting prepared. The waiter would serve him some wine. After that, I have the order is ready. Now next thing what I need to do is I would having a return call again. So for that I would simply copy paste it and draw it to the third line. So third line what it says, it is pick up. So again I would go to this text over here, draw it and write it as pick up. After that I would select it and bold, make it bold. After that the pointer tool, again I switch it back. Okay, now you could see the sequence, how the sequence has started and how beautiful it looks. After that I have to draw one more line in between somewhere over here. So what I would do, I would create an activity in between this and I would draw another message line. You could simply Control C, Control V in order to show this thing. No need to drag it again and again, that would save a lot of your time. And here I would write it as serve food. For that I would be again taking the text box and I would write it as serve food. Again select all this thing and I will make it as bold. Again switch back to pointer tool. Now this activity is complete. After that, after he has consumed his food, he has to make a payment. So next activation would be on this particular line. So you just see this graph and draw it like this way. Okay, and after that a message would start from here. Sorry, you have to create a message which should start from here and go till here. Sorry, make it as simple. After it has reached this activity, here what you are doing essentially, here you are making a payment. So again you go to this text over here and write it as pay and make it as bold. There are no more activities that are happening in this sequence diagram. So when I created, you could see easily I have captured all set of details for this sequence diagram. Now I have option to save it as any sort of pictures. So you could select as let's say I select a PDF. You could select it as your JPEG file or GIF file so that it goes easy for your reference. Now save it as drawing 1. Okay, now we'll see how it looks like. So when we click on this drawing 1, okay, when you go to this particular part, you should see the drawing as a like this because we didn't switch back to the pointer tool. That's the reason. Now save it as drawing 1. Now open drawing 1. It's essentially saved as visual file. You have to save it as your JPEG file. Now click on it, would ask for override. Click on yes, click on OK. Now go to this particular part and click on drawing. Now your entire image is there, the sequence diagram. Now you could copy paste the sequence diagram on your functional specification document or any of the document wherein you want to indent it. The next diagram on which we are going to have hands-on is the collaboration diagram. Again we have to repeat the same thing. We have to click on create, and after clicking on create, a canvas is presented in front of us, and on this canvas we are going to design our this thing, collaboration diagram. For that, again, you have to go to software and databases, software design. We would be needing a collaboration diagram. So for that, we would go and click on UML collaboration US matrix. After that, when we refer this particular diagram, so there are 4 blocks. So these blocks are called as classifier roles. So there are member, there is UI, user interface, then there is again member, then there's a book, and then there's a copy. And in between them are the essential steps which are depicted in front in terms of your notes or your constraints. So we'll start creating these diagrams. So for that, we would first need 4 blocks, the classifier roles. So this is the first block that I have kept over here, and this is the second block. Now when I am clicking on this particular block, you could see some arrows. So just go on clicking on those arrows. So it would automatically give the necessary direction to this block. Now I want it above it, so I would click on this particular block. Below it, I would click on this particular block. So we have 5 blocks in all together. We have 5 blocks in 5 in 4 different directions. So we would quickly cross check with our specimen that I have created for reference. We have 5 blocks. The arrow is going from member to UI, then UI to book, and then UI to member, and UI to copy. So we have all the 4 different direction and the members. Now what we are going to do is take a text, and below it I would write it as member block or the member classifier role. I'll go and click on. Again I would come back to the pointer tool. So this is your member block. So the moment you drag or drop something outside of this canvas, you could see a section is getting extended. So that is a case when you would like to extend your particular UML diagram in any for any XYZ reason. You could do so by putting a block in this empty space, so your diagram would get extended. So typically in real project scenario, you may you may be asked, or there may be a need wherein you have to extend a particular diagram so that it captures all the details in a detailed manner for the development team. Then we have book. So for book also I would do the same thing. Click on this. I would create a book classifier role, double click on it, bold, and again I would go back to my pointer tool. So if it is not visible to you, you could increase its font size as well. So let's say I have increased its font size to 16 points. Now it is visible to everyone. Now similarly, I would create the blocks for copy and member in the appropriate locations. So same thing I would repeat. Create on text, click over here. This is again member, double click on it, then click on bold, and again go back to my pointer tool. Then drag and drop over here. Now there is another way to do this formatting. Just click on it, click on format painter, and click this icon, and this is done. Next we would be having a copy. So click on copy, go back to my pointer tool, align it, click on this member, format painter, and click on copy. Now I had 4 blocks with me. Now I also have a block called as UI. So I would click over here, I would write it as user interface or UI. On bold, again go back to my pointer tool, and now I can align it anywhere I feel like. The same thing you have to do, format painter, and this is my user interface. So if you want it in a single line, just drag these things. So we have created our initial blocks based on the classifier role. We have given the necessary flow direction associated with each role. Now we are going to create the nodes, that is your reserve copy or the constraints. So this is your reserve copy. Now I will create a text and bring in it. It doesn't allow me to write something inside it. So what I would do, I would write that reserve copy and go back to my pointer tool and drag and drop it over here. So that is my reserve copy. If I want, I can make it as bold as well. Next thing is validate membership, check privileges. For that, what I am going to do, I'm going to hit the notepad and I'm going to write these things first. That is 1.1 is validate membership. 1.2 is check privileges. I will simply copy it and go back to my diagram. I would again pull in constraint over here, go to the text mode and simply paste it. Then I would select them bold. I want to make them left aligned. Sorry, I can do so as well. Then go back to my pointer tool again and I will place it somewhere over here. Or for a better readability, I can put it over here as well. And we can do some coloring part as orange thing. And this particular part, I would apply a color theme as yellow. I can do that as well. After that, we have another thing, that is check availability and mark as reserved. That is 2.1 check availability and 2.2 is mark as reserved. We'll again copy it, go back to my main diagram, take in constraint object again, go back to the text mode, select them all, bold, align them as left, go back to my pointer tool, make it as aligned with the earlier diagram. And similar way, we can also do the format painter for these shapes as well. So we have these things with us. Now there is one more final criteria or the constraint, that is your check status. So for that also we would do the same thing and write it as 3.1 check status, 3.2 change status, 3.3 set alert on first due copy. Control A, C, everything. Go back to our main diagram, click on constraint, go to the text mode, click on the text item, select all, bold, left align, and go back to the pointer tool. After that, I'll select on the text item, make it in one particular line, click on this, format shape as this thing. Now my diagram is ready. So I would do the same thing, click on this, save as, not drawing, what you would save it as JPEG image on our particular folder. So click on save, OK. Now let me go to my particular folder, desktop, this particular folder. It is in this particular location. Now see, this diagram you can copy paste in any of the functional spec or any of the document wherein you are intending to place it. So this is about your collaboration diagram. So in similar lines, now we would try a new diagram. For that, we would create a new blank template, and this time we would create this state chart diagram. So this is the specimen diagram that we have that we intend to create. So for that, we would go again to more shapes, software and database, software, and there we would search for state chart diagram. So all the elements of state chart diagram are available on the left hand side, the stencils. So we would be needing the state first, that is the initial state. So we define our initial state over here. We could put the color as black. Then we need 3 transitions or the 3 states. So it create this particular state, click on write, one more state, click on write the third state. So we essentially need 3 states to complete this particular diagram, and we need a connector from here to here as well, so that we have done. After that, what we need to do is I have to align it. So I have aligned it. After that, I want to show the items within those states. First is enrollment, being taught, and final exam. So same thing I would do over here. Go on text, enrollment, bold, I want it as 16 pixels is too huge, make it as 14 pixels. Go back, switch back to my pointer to, this is my enrollment, then being taught and final exam. So I can simply copy paste it as well, Control C, Control V, Control C, Control V. This is your being taught, and this is your final exam. So if you copy paste some of the elements in your particular diagram, it would be easier for you to save some time when you are creating these kind of diagrams. After that, we have to show some states. So we will show one more initial state over here, and the transition from here. I will bring the particular transition from here and join it over here. After that, I want the final end state. So for end state, we have a circle with a dot. So here I would do the same coloring thing, black, same coloring thing, black, circle with a dot. And I would do one more transition from here till here, a straight line. Now in between them, I want to do some connectivity. So what I would do, I click on connector and do the connectivity till here. So this connectivity you can do from here to here, or better is you can do it in this way as well, depending on how you want the connector to be there for you. So you can do it this way also. Now switch back to your pointer tool. You got the arrow of your desired shape like this. Same thing we would do for this thing also, these two arrows as well. We'll go with the connector, click on this and join it over here. Again we will go to the connector, click on this and join to this particular thing, and again we'll switch back to the pointer tool. If you feel it is not aligning, you can change the alignment as well by simply clicking on the arrow keys that are available on your keyboard. After that, we have to enter the necessary text like term started, classes, end, all those things, so that we can do it with the help of this text. started, go back to your pointer tool, double click this, bold, we'll keep it as 10 over here, switch back to the pointer tool, copy paste it over here, double click on this, this is our classes end. Okay, after that we have to write these criteria like cancelled, student, dropped. Here you could write it as cancelled. Simply copy paste it. Cancelled. You can align it to the left. Again, you could copy paste it. This is the case when student is dropped. Write it as student dropped. Align it as left. After that, see if there are any more criteria. Yes. Seminar size greater than 0 and seminar size equal to 0 within these square brackets. So for that also we would be doing the same thing. Simply copy paste it and write it as seminar size greater than 0 within angle bracket like it is created in this diagram. Then seminar size equal to 0. So see, control V, seminar size, here it would be instead of greater than equal to 0. After that there is only one item pending, that is closed. Control C, control V, over here you could write it as closed. Left align it and your diagram is complete. The state chart diagram is complete. So similar way you can save it as not drawing object as JPEG file. Okay, now let's go into an folder and see. Now the state chart diagram is ready. Now this image can be copy pasted in any of the specs wherein you want to include it. So this way you could practice the other diagrams like your activity diagram or deployment diagram in your this particular, or for that matter the component diagram in this particular Visio tool. So Visio tool is a paid tool. You could use Visio tool if you have a paid subscription for it. Else you could leverage your regular Lucid chart trial copy or Glyphy for that matter. So you could use that tool as well. There is one more tool that is called as Argo UML. This particular tool also provides the same set of functionality, but this tool doesn't support UML 2.5. It only supports up till UML 1.4. So you need to keep that in mind. Here also if you go over there, you would see use case diagram, class diagram, sequence diagram, collaboration diagram, state chart diagram, activity diagram, and deployment diagram. You may not be able to create all the 9 types of diagram that are present in UML. So I would recommend if you would like to have a tool which is free in nature and your requirements are very basic, let's say you want to just create the use case, then Argo UML is the best tool which you could use for creating use cases free of cost. If your requirements are a bit at a higher side, then Visio is always preferred tool which you could use. In most of the industry, in most of the software projects, we use Visio for doing this process modeling stuff.